Greetings, fellow mathematicians. We're going to take a look at a trig integral that involves powers of tangent and secants. These are a little bit more complicated, but for the following reason. They're only more complicated due to the derivatives of tangent and secant being more complicated. Secant squared and secant x times tangent x. As long as you know those two basic trig derivatives, you'll be able to guide yourself through these problems. Now don't try to memorize all these different possibilities, even powers of tangent, odd powers of secant. The unifying idea, split off factors for du, convert the remaining ones using Pythagorean identities. And let's go ahead and make a wrong attempt here, and I want to point out why. Let's suppose we tried splitting off a factor of tangent and secant. So let's go ahead and try splitting off one power of tangent. That'll leave us with tangent of x, split off one factor of secant, and we'll be left with, at the end here, secant x times tangent x. All right, now mathematically, this is correct. We have rewritten this correctly, but let's point out why this would not work. The factors that you split off, you want that to be for your du. Now what would then be the u? Just work backwards. What differentiates to secant times tangent? Secant. You would use a u substitution here as secant. Now the middle part here, that's easy to convert. If u is secant of x, that'll convert to u cubed. But you will not be able to convert tangent, just tangent of x, to the first power using your substitution. So you want to split off factors in a way that you'll be left with typically even powers to do the conversion using Pythagorean identities. So let's go ahead and forget about this approach. Instead of splitting off secant times tangent, let's split off a secant squared factor. And we'll see where that gets us. All right, so we're going to leave tangent squared alone. We're going to split off secant squared. From secant to the fourth, we'll be left with secant squared. And then the factor that we're splitting off, we're going to put at the end multiplying dx. All right, and here it should work itself out. You want this to be du. What differentiates to secant squared? Tangent. We're going to choose as our u substitution, u equals tangent of x. All right, and if you calculate your differential du, that comes out to secant squared of x times dx. So you can convert here. These last two terms convert to du. Using your substitution, u equals tangent. Tangent squared, that converts to u squared. And like we expect from earlier problems involving powers of sines and cosines, the other terms, we're going to have to use a Pythagorean identity. Now, it is a little bit harder to memorize correctly your Pythagorean identities involving tangent and secant, because it does make a difference which side you put tangent squared on and secant squared on, but you probably already know this. So here, we're going to convert secant squared of x and rewrite it as 1 plus tangent squared. All right, and now we can rewrite secant squared in terms of our substitution. Now we just plug in u for tangent of x, and that's going to become u squared. All right, and that's pretty much it. It falls into place. We've converted everything from x to u. The middle term here, that's 1 plus u squared. And now we just need to set up our integral here. Let's just write it out. We have the integral of u squared times 1 plus u squared du. And from here, it should be very simple. Just go ahead and distribute. And you'll get u squared. and then correctly multiply there by adding the powers. U squared times u squared will give u to the fourth. And it should be very simple at this point to apply the power rule to each of those two terms. So we'll get 1/3 u cubed, and then plus 1/5 times u to the fifth. And then plus c. And we just back substitute. Our substitution that we used was u equals tangent of x. And we just go ahead and plug that in here. We're going to get our antiderivative involving powers of tangent. So we get it here as 1/3 times tangent cubed of x, and then plus 1/5 times tangent to the fifth power of x. And that is it. All right. Now I want to make a point here. Make sure you make an attempt to really understand why you're splitting off certain factors, and that is due here to the derivatives of tangent and secant being slightly more complicated. Either split off a secant squared or split off secant times tangent. As long as you keep this in mind, you don't have to memorize all these different possibilities for combinations of even and odd powers for sines, cosines, and tangents and secants. Hope you enjoyed the video. If you're learning a lot, support the channel, like and subscribe.